Okay, so these stators over here are at school. I went over and I took pictures of it. So you can see you got 1, 2, 3, right? There's 2 sets of wires connected here. And that's how these things are joined together, right? You're going to see in a moment how they're arranged. But you can see that these wires wrap around and around and around and around. What they're wrapping around is these segments. That's what they're connected to. These individual segments. Okay, you have a break here, and there's change in voltage, and as a result, you get different ones of these activated, so to speak. Right? They're north and south, and north and south, and north and south, and north and south. Now you got a rotor that's north and south, and north and south, and north and south, and north and south. So now you got this one, once again, that has the current flowing through it that can increase the magnetic field. And as those norths and souths line up with these norths and souths, you have a continuous path of AC current that's being broken here, that's inducing electricity in these, and as a result, they come out of these into the other components in the alternator. This is the moneymaker. This is where the power of the alternator comes from. All right, so here we go. So the stator windings. This is the arrangement of those 3 sets of windings. This is called a Y-wound connection. Can you figure out why? Right, you look and they are arranged in a Y. One lead from each winding is connected in one common place. Right, so all 3 of them are tied together in one knot, and then they branch outward. It's usually found in applications that do not require high amperage output. Current is combined due to 2 leads always being in series with each other. Lower current capabilities will come out of these. All right, so you always have a pathway. 1, 2, 1, 2, 1, 2, 1, 2, right? There's always 2 in series. When you look at wiring diagrams of alternators, you will see that designation on that alternator in that diagram. Now, the other one that we have, right, so you can see over here, before I go further, here is 1 wire that are tied together, and then 1, 2, 3. This one's called delta wound connection, and it makes a delta symbol, right? Attaches the lead of one end of the winding to the lead at the other end of the next winding. Commonly used in applications that require high amperage output, and it's usually smaller as an alternator than a Y-wound design alternator. Current flows in parallel. Therefore, we have higher output, right? The last one was in series. This one's in parallel. And if you look here, you'll see there's one connection, there's one connection, there's one connection. 2 wires to it. All right? If you look back at the stator, there's one there that the 3 eyelets are sticking up. That is that's a delta design. Okay, now we have the rectifier bridge. Right? It's in the back of the alternator. That is what these windings connect to. This contains the diodes that convert AC to DC. Diodes are constructed of semiconductor material, usually silicone, and operate as one-way electrical check valves that permit the current to flow only in one direction. AC generators use 6 diodes, 1 positive and 1 negative, for each of the 3 stator windings. That converts the alternating current to direct current. The symbol for a diode shown there. This assembly, right, you have 6 diodes. These are called the diode trio. They are responsible for taking this and chopping off the negatives on that AC current, so you're only left with positive. So now here is how a generator operates, and you can see your diodes here. 1, 2, 3, 4, 5, 6. Right, this shows the current flow. Here's a Y-wound connection. And let's go through the steps of what happens here. The drive belt turns the rotor inside the stator winding. Okay, it's turning the rotor. The magnetic field of the rotor generates a voltage in the stator windings, done by the field current making that magnetic field bigger. So that magnetic field induces the magnetic field in the stator winding, and that stator winding is what generates the electricity that flows out. The voltage is changed to direct current by the rectification diodes from these diodes here. Now, if you notice here, notice that there's 3 sets of these. Okay, your alternator is broken down into 3 phases. So we have 3 sets of these. So no matter what, once we chop these off, we're left with current all the time. As the rotor continues to rotate, this sine wave current is induced in each of the 3 windings of the stator. Okay, this is just what we saw before. As we go around, as the magnetic fields break apart, we get our upwards or downwards motion of the sine wave. Okay, so naturally, if a north is connected to a south and they break apart, we get AC voltage. If a north is connected to a north, no magnetic field, no AC voltage. When a south is connected to a north and it breaks apart, voltage. When a south is connected to a south, no voltage. So that's what's happening at these middles, right? This is a north to a north and a south to a south. This is a north to a south and a north to a south. Or actually, this one would be a south to a north. Because each of the 3 windings generate a sine wave current, the resulting currents combine to form 3-phase voltage output. Right? So each one of those windings creates its own thing as that rotor turns inside that stator. As a result, we get 3 sets of those magnetic fields forming. The voltage regulator controls the output voltage by controlling the field current. Sensing voltage, right? That is what the system is doing. It feeds back so it knows what's going on, is monitored by the regulator, and it's used to control the field current. About 3 amps is controlled by increasing resistance or turning the current on and off in the duty cycle. The higher the current, the higher the voltage output. So if you look over here, here is the field coil, right? That's the rotor. That's inside the rotor. You can see it's grounded, and we control the voltage to it. We have a variable resistor here that bumps this up or brings it down, all depending on the sensing voltage that's being looked at by the voltage regulator, right? So roughly 3 amps pass through this into this. If we need to bring it up, we increase it to 5 amps. If we discover that we don't need that much going on, we bring it down to 2 amps. So there you go. You know how an alternator works now. So in the discussion area, post something, and if you have questions, ask me, and I'm happy to clear it up. But that is how an alternator operates. Pretty cool, right? Okay. Talk to you soon.